Hey guys, today we're going to be learning about particle-to-particle stoichiometry. It's similar to mass-to-mass stoichiometry in terms of 3 steps. You'll also see that some of these problems are not direct particle-to-particle and that they have more of a mixed review, where you'll be doing maybe a particle-to-mass or mass-to-particle problem. Not all stoichiometry starts and ends with the same unit, so it's good to see those mixed review problems. The first thing I want to point out is that the term molecule or particle can mean other things. So in chemistry, they have multiple terms meaning the same thing. So you just want to make sure that when you're reading the word problem, you know what they're saying. So the word molecule can also be listed as atom, ion, formula unit, or particle. So if they say how many particles are in this many, the word particle itself is meaning the same thing as molecule. You do the problem the same way. So you'll see here on, let's just say number 2, it'll say how many molecules of bromine pentafluoride form when you have 384 grams of bromine. Molecules is also particles, so it's the same thing, just written differently. So we're going to go through and talk about how to solve for these problems, and then you'll try a few additional practice problems on your own. The first step is always, and you can see this on number 1, is to write and balance the chemical equation. Now for my second period, my regular class, you guys will only be balancing, so you would be doing what's in red, and I would give you what's in purple on the quiz. And my 5th and 6th period, the honors kiddos, you will need to both write and balance the chemical equation. I want to point out that bromine and fluorine are both diatomics. That's why there's these 2's here. Without those 2's, that would affect your balancing, so you want to make sure you have that. And then at the end, it talks about bromine pentafluoride, so that penta is why there's a 5 there. Then you go through and balance. Balancing is key for stoichiometry. It's very important that your coefficients are correct, and I think you guys have all figured that out with mass-to-mass stoichiometry. If your balancing is incorrect, your coefficients are wrong, of course, and if your coefficients are wrong, you're going to be plugging in the wrong coefficients to your problem. So make sure you're balancing correctly and that your equations are written out correctly. Now we're actually going to start with number 3 and then go to number 2, and that's because number 3 is a particle-to-particle problem, and that's where I like to normally start. And then we'll do something that's considered more of a mixed review, where you're taking a mass-to-mass stoich problem and kind of merging it with a particle-to-particle problem. So let's start with number 3. Number 3 says how many molecules of bromine react with 1.11 times 10 to the 20th molecules of fluoride or fluorine. Now we know that fluorine is a diatomic, and when listed alone is going to have that 2. That's why you'll see that I have the 2 next to F. The reason I have the F's all highlighted in pink and the B's all highlighted in blue is to show you where that transition of elements is within the problem. So you're transitioning from fluorine to bromine on that mole-to-mole step. That's where you take it from one chemical and go into the next. It's good also to cross out units to show what's been canceled. That also helps a lot of students through these problems. Now what you always do first, just like you did for mass-to-mass stoichiometry, is to go ahead and list your given. My given here is 1.11 times 10 to the 20th. You'll see that I put it in parentheses, and that's because anytime you have a number in exponent form or exponential form, we need parentheses. It's just best to be in a habit of doing that. Sometimes if you don't, your number can get kind of weird. Now if you're wondering how am I supposed to put it in not parentheses, but how am I supposed to put an exponent in my calculator? Many calculators have a button that looks like this. So when you go to write 1.11 times 10 to the 20th, when you get to the 10 to the 20th, you put your 10, you put your caret, and then you put your 20, and that will boost up the 20 to an exponent and will work. Other calculators have like a YX function that will do the same thing. Make sure that you're practicing with it though before, of course, your upcoming assessment, so that you feel comfortable with putting it in. Okay, so we have 1.11 times 10 to the 20th molecules, because that's what they listed here. And you want to write what they actually have. So don't put like atoms or something. Even though they mean the same thing, you want to write like what they actually have. Of fluorine. This first number is what we call Avogadro's number, 1 mole of any compound has this many particles. So this right here is kind of a constant fraction that will always look the same if you're going from particle to particle. Your Avogadro's number will go to the bottom so that your molecules can cancel, and this will always be 1 mole on top. And I even put always 1. This will put you into moles so that you can go into the mole to mole step, and from the mole to mole step you'll go back into particles. Your molecules cancel, you're left with moles. Again, this is always 1 mole, and 1 mole of anything is always Avogadro's number. Then you go into your mole to mole step. What you're trying to get rid of goes to the bottom, and what you're trying to solve for goes to the top. What I'm trying to get rid of is fluorine because that's what I originally started with, and what we want to go into is bromine. So moles of fluorine are going to cancel, and moles of bromine are going to be where we're moving into. These numbers, where are they coming from? This is not always 1, and this is not always going to be a 5. This is coming from the balanced chemical equation up above. You need to find fluorine and figure out what coefficient is sitting in front of it. There's a 5, so that's why that 5 drops down here. Whatever coefficient was sitting in front of your chemical for the mole to mole step only, you need to plug in here. Not over here. This is always 1, this is always 1. This is where you put your coefficients. This right here is a 1 because there's a 1 here. This could have been a different number just depending on what the coefficient was, but in this case it was a 1. Now we're in moles of bromine, but we want to get out of moles because the problem wants to know how many molecules of bromine will need to react with the molecules of fluorine. So we're going to go ahead and put 1 mole of bromine here, and then we're going to put Avogadro's number on top. And we're putting Avogadro's number because we're now solving for molecules. So anytime you have the word molecule, particle, atom, ion, or formula unit in a problem, you need to write Avogadro's number. Avogadro's number does need to be memorized, and it's 6.022 times 10 to the 23rd. What is nice about a particle-to-particle problem is that you don't have to plug in your calculator this step, though you should express it and write it down, and you don't have to write this step in. This is only for particle-to-particle problems. So the only thing you actually have to plug into your calculator is this right here and this step right here. Why is that? Most of you guys can see that the 6.022 times 10 to the 23rd will cancel each other out, and they do. So what ends up happening is really all you need to do is open a parentheses and put 1.11 times 10 to the 20th, close your parenthesis, hit divide because the 1's on top, and divide it by 5, and you will get your answer right here. The answer is 2.22 times 10 to the 19th molecules of bromine. Of course, it's very important that you try this on your own, so maybe pause the video and try plugging this in on your own to make sure that this is what you get. If this is not what you're getting, check with somebody next to you. Say, hey, did you get this number? If you did, especially if they have the same calculator, have them show you how they plugged it in. We do that in class a lot of times. I'll show you mine. I work it out with you guys, and a lot of times someone in your group is getting it, but you're not, and so they'll end up, showing you how they plugged it in. Now this problem up above, number 2, is a little different. What makes number 2 different is that it's not a straight particle-to-particle problem, and you're not always going to get straight particle-to-particle problems. This one is a mass. I know we start with mass because my given is in grams. So it's a mass to particle problem. Now you'll see I wrote a little X through the excess of fluorine. I did that because anytime in a word problem, I already said this on a previous video, but anytime on a word problem they say excess of something, a lot of students start to kind of wonder, where am I supposed to plug that in? You don't need to. So you can actually just ignore it and move on with your problem. So we're going to begin with our given amount, which is 384 grams of bromine, or Br2, because it's diatomic. You write that right here. Then you put your first X in line. Just so you know, a mass to particle problem is also 3 steps, just like your particle to particle problem is 3 steps. Now because we're in grams, we're going to put our grams of bromine at the bottom, and instead of putting Avogadro's number, we need to put the molar mass of bromine. Now the molar mass of 1 Br is going to be 79, I believe, 0.904, but we need to go ahead and multiply that by 2 because bromine's a diatomic, so don't forget that. I think one of the most common errors I see in grading these quizzes and tests is that students forget it's a diatomic, so sometimes they'll balance it wrong, but they'll also forget it's a diatomic here and not multiply the mass by 2, so this number will be off because this number was off over here. So if it's a diatomic and there's a little 2 here, you need to multiply its mass by 2. Now this will be just 1 mole, and that says that 1 mole of Br2 weighs this much. That's molar mass. Our grams of Br2 cancel, and now we're in moles of Br2. We do our next excellent line. This is our mole-to-mole step that is in every Stoich problem. What this step does is it gets us out of one chemical and into the next. We're getting out of bromine, and we're solving for BRF5, because they want to know, if you have 384 grams of bromine, how many molecules will you get out of that of bromine pentafluoride? So we need to go ahead and figure that out. So we're going to go ahead and put moles of bromine pentafluoride here. If we ended the problem without doing this step, our answer would be in moles, but they want molecules. Now the 2 comes from the coefficient, and that 1 comes from the coefficient. Our next X line is going to put us in moles of BRF5 at the bottom to cancel our moles. This is always 1 at the bottom here, always 1 on top here. These are always 1s. This number is Avogadro's number, and that is because we're writing molecules. So anytime you see, again, molecule, particle, formula unit, ion, atom, you're writing Avogadro's number in one of these 3 steps if you come across that unit. All right, so because we're in molecules here, and that's what they want, we need to write Avogadro's number. That, again, you need to make sure you memorize. It's not hard, but you just need to know it. You will see I put parentheses here. Why is it that I'm having to plug it in this time? Because Avogadro's number is not at the bottom here, they don't cancel out, and I have to plug all of this in. So I'm going to go over how to do that now, and you guys can play and pause the video and try this on your own and plug it in. All right, so you start with 384. You're going to divide that 384 by 159.81. You're going to multiply it by 2, and then you're going to multiply it and then open a parentheses and plug in 6.022 times 10 to the 23rd. Don't forget your caret. Close your parentheses, hit enter, and you should get 2.89 times 10 to the 24th molecules of BRF5. It's very important as you show your work that throughout the problem you're putting your number, your unit, and your compound throughout the whole problem. Many students just show units here and at the end, and they get lost throughout their problem. The point is to be able to cancel our units. So without units, we're not being able to cancel anything. Canceling units, it's always when they're diagonal. If you put them next to each other, they square each other. So you always want to be left with the unit they're asking for in the problem. All right, so there are a few more problems to try. Make sure that you really try to practice the entire thing, anything I give you, because you don't get too much practice. And then make sure as you practice that you're looking through the key. You will also get kind of a mixed review closer to the assessment too. So I always give kind of a big, large mixed review because, again, a lot of problems are not just straight mass to mass or particle to particle. You're going to get also some that are a little bit more mixed. On the assessments, I like to do, I'll do a mole to mole, I'll do a mass to mass, I'll do a particle to particle, and I'll do some mixed ones. So you're gonna see a variety, but it's just important. The mixed part is really important to practice because I think out of everything, that's where people start to get a little confused. All right, go ahead and start working on the practice now.